things evolved over the years. In the last few years, we've introduced this concept of metaparameters to models. I'm going to assume that all of my listeners here are generally familiar with models and how to train them, and are familiar with the words parameter and hyperparameters. So parameters are those weights and biases inside the model. It's what the model learns, and they stay with the model. And then the hyperparameters are those things we use to tune the training of the model to get the best result out of it. Things like the batch size, or the learning rate, or the learning rate scheduler, or the layer regularization. But they don't stay with the model. Okay. Now, metaparameters is like, it goes a step further, is now that we're designing our models as patterns, and those patterns take parameters, the metaparameters are like the configuration. Think of it as a specification. A standard model design is kind of like a factory now. And you can think of each one of these convolutional groups up here is like a station in the factory, and it has certain patterns that it can produce at that factory point. Okay, but there's some variability in it. Okay, and so what you do is you pass in a specification that gets pushed down to the machines, and they produce that item, right? Conceptually the same thing here. That's what metaparameters do. Okay. Typically, the metaparameters might specify like the number of blocks that are going to be in a group. And then for the group, the number of input filters, and optionally the number of output filters. So in some convolutional groups, it's generally a convention in most models that every convolutional block in a group has the same number of filters. The one exception we see in there in some state-of-the-art models, or I call them SOTAs, okay, is that you have one number for input and one number for output. Well, the output one only applies to the last convolutional block. Another thing that sort of evolved starting with 2015, and it's pretty consistent now, early convolutional models, we called them CovNets, okay, because they had one simple pattern: convolution pooling, convolution pooling, convolution pooling. Okay, and pooling is a reduction step. Okay, in modern models, we delay the pooling or the reduction, okay, dimensionality reduction, to the end of a group. So it only happens once in the group, doesn't happen in the blocks. There are some state-of-the-art ones that do it at the beginning, but the majority of do them at the end. But the important thing is it happens only once in a group.